Hello everyone, my name is Justin and welcome back to the channel. Today we're showcasing Google's Teachable Machine, a supervised learning platform. I'm going to demo a project I built, an instrument classifier that sorts images into 4 families: woodwinds, brass, strings, and percussions, the 4 main music families. I'll show you where I got the training data, how I set up a 90-10 train test split, train the model, and then test it live with unseen images to see how accurate it really is and what its limitations may be. With that being said, let's get started. First, we're going to be at teachablemachine.withgoogle.com/train, and we're going to select image project. Image project. We're going to use a standard image model for this one. We don't need an embedded image model. Now, first, I just want to reiterate exactly what the application and what the project is for. We're going to be using this machine learning platform to demonstrate how we can provide data inputs to machine learning, a supervised learning, and it can predict, or I should say analyze the data we give it and categorize it accordingly in its proper class. Now, as mentioned before, we have 4 music families, thus we're going to need 4 classes. So let's click add class, and let's add these music classes accordingly. First is going to be the brass, then woodwinds, then strings, then percussion. Now that we have these 4 classes set up, we're going to upload our images into these classes as samples to then use that to train the model. Now we got these images, from Google. We just proceeded to Google brass instruments or woodwind instruments, and once it pulled up that list, we downloaded those images onto the File Explorer as we're about to demonstrate to you, and they will be categorized accordingly. Now, with each of these images, they are all used and going to be, well, you'll see. Now, first, let's start with the brass. Let's click the upload button here, and we'll start with the brass. Now, we're not going to use all these images. This is what I was telling you about with the 90-10 split, which I almost revealed just now. The 90-10 split is that we're going to use 90% of these images to train, and we're going to use the last 10% to confirm or to test that the machine is actually learning and can categorize properly. It wouldn't be fair if we gave it the material and that's what we tested upon. So we're going to send most of these, but not all of these, into the sampler. And we're going to do the same thing for woodwinds. Once again, not using all the images. Same for strings. And the same for percussion. Now that all of our samples have been loaded into their respective classes, we're just going to train the model. And we'll click on train. Now, the model has been trained and it's ready to receive its test inputs. So what we're going to do is we're going to click on this and switch this to File. And I'm going to move the File Explorer out of the way for you guys so you can see the sample in question when we put it. And let's put our first test from the percussion. We're going to put the xylophone and see what it gives us. The xylophone gives us 96% percussion and 4% woodwind. Now, it probably gave us that result based off of the glockenspiel that we can see here, which looks very similar to the xylophone, but either which way, 96%, that's pretty good. Only a 4% margin of error. That's not bad at all. Let's try the other percussion image, the triangle, and see what we get. Now, in the triangle, according to the machine, it's not as obvious that this is a percussion instrument because we're only at 60%, with 33% at woodwind and the remaining percentages in brass and strings accordingly. So with that being said, even though this image clearly shows a striking tool here to strike the triangle, the machine has not learned enough, it has not seen enough to recognize that this is a percussion instrument. Now let's try this again with the strings and let's see what we can get from the strings. Put in my ukulele here. And you can see it's almost even with both woodwinds and strings. Even though the ukulele is a string instrument, it's almost even, and even has a little bit of percussion in there. This could be based off of the images that we have fed the tool, in that it's not clear what is a woodwind and what is a string. But then this kind of comes back to the limitations we were talking about before. Your machine learning tool can be limited by the amount of data that you can put into it, and also might be limited by the quality of the data you can put into it. Now we'll talk more about data quality in a moment, but I just wanted to voice that out there. Let's try the other string image while we're here. Now you can see the violin, instant recognition as a string instrument, 100%. It could be because of this cello image here and they look so similar, but it could also be that the machine has just learned from this cello image and is applying it accordingly to the strings. Now we're going to test the woodwinds. And the sax is 88% a woodwind, and it's split amongst the rest. That last 12% looks like it's 9, and then probably 2 and 1. But either which way, you can see it's resounding that is leaning towards it's a woodwind, which is correct. But now let's put the other woodwind tester, and you can see the soprano sax gets a 100%. It's very confident that it is a woodwind instrument, which it is. So based off of the images that we put in here, you can see some of them have very distinct features similar to a soprano sax, such as the standard clarinet here. But still, the fact that it was able to recognize the soprano sax with this color, not as brass, is quite impressive. Now let's put our last two brass entries in there. As you can see, we have both a trumpet and a bass trumpet, which look very, very similar. So I'm curious to see how the trumpet will fare in the output section. 100% brass, which makes sense because it recognizes it as a brass instrument. And now let's try the tuba and see where we get. 95% brass and only 5% strings. Now that's pretty solid. That is quite solid. Now I believe it's using the coloring, potentially trying to determine what the tuba is, but it is a brass instrument, and using the images that were provided to this system as samples, it was able to create full-on classifications, and they were semi-accurate. The brass instruments tended to be more accurate than others, but you can see that the limitations are based off truly the data you can input into it. The more data, the more complete the data, the more accurate the machine's output will be. This is a perfect example of seeing that the more you feed it, the better it gets, the stronger it gets. So with that being said, thank you for coming to the video. I hope you enjoyed.